All right, so the beginning of Unit 8 has to deal with what we call trigonometry. Now, let me talk about ratios. Now, the word ratios is the fancy way of saying fractions, okay? But on the right triangle, let me draw a right triangle here. On the right triangle, we know the big side. We know the name of the big side. Let me call this hypotenuse. Now, the other two sides, they're going to have names. One of them is going to be called adjacent, and the other one's going to be called opposite. Now, mathematics, adjacent means next to, right? We saw that in the first semester. Adjacent means close to or next to. Opposite means far away. So let me introduce you guys to a Greek letter called theta. It looks like a zero with a little line in between. So let me put a theta in one of my corners, not the 90 degrees, any other corner. Now, this Greek letter, it's called theta, it means measurement. Okay, so based on this angle, because notice how I put it in one corner, based on that angle, remember I said the sides are going to be called opposite and adjacent. Opposite means far away, adjacent means close to. So I'm going to say this side on this over here, let me call this opposite. Right, is the one side that is farthest away from theta, right? And this other side here at the bottom, let me call this adjacent. So we know the hypotenuse is the biggest side. There's no way of changing that. Now, opposite and adjacent is based on theta. Where do I place theta? Right. Opposite is far away from that corner and adjacent is close to. Now we're going to learn 6 different ratios, 6 different fractions. There's 3 sides of the fraction of the triangle, and if I make fractions, there's 6 possible fractions that I can make. One of them we're going to call sine. We're going to call that sine, and we're going to say sine. As a matter of fact, I'm going to abbreviate that as SIN. I'm going to abbreviate it to 3 letters. The reason why we're going to abbreviate this because we're going to be using calculators. And if I put too many letters on the key of a calculator, the font is going to be pretty small. So I'm going to abbreviate that using the first 3 letters. And we're going to call this sine of something. So sine of theta in this case. We still pronounce it, even though it's S-I-N, we still pronounce it as sine. Don't call it a sin, right? We still sine, even though I'm using SIN, so because I abbreviated to 3 letters, I'm going to say sine of theta is going to be opposite over hypotenuse. It might look like mumbo jumbo right now, but we'll get to it in a minute. So sine is going to be opposite over hypotenuse. Then we're going to learn cosine. Let me write the whole name first. Cosine. Then the way I'm going to abbreviate cosine is only using the first 3 letters. So I'm going to call this COS of theta, but we're still going to pronounce it as cosine. Again, I'm just going to abbreviate it as 3 letters because we're going to use these words in keys of a calculator. So cosine of theta is going to be adjacent over hypotenuse. So cosine is going to be adjacent over hypotenuse. Now, the third side we're going to learn, because I said we're going to learn 6. The third ratio we're going to call is going to be tangent. Tangent. I'm going to write the whole name, tangent. But just like before, I'm going to abbreviate it using the first 3 letters. So I'm going to call this TAN of theta. Even though I'm just writing TAN, I'm still going to read this as tangent. So tangent of theta is going to be opposite over adjacent. Now, let me highlight a few letters in blue here. the first letter. I'm gonna highlight the first letter of each word. So notice I'm writing it in blue. Let me write the first letter of each word. We're gonna have an acronym. This acronym is going to help you guys out. This acronym is going to be SOH CAH TOA. This acronym is going to help you guys out. What SOH CAH TOA stands for is sine is opposite over hypotenuse. Do you notice the letters I highlighted? Remember I said I was going to highlight the first letter of each word. Notice how I highlighted the S, then the O, and then the H. Sine is opposite over hypotenuse. Cosine, as you guys notice, is adjacent over hypotenuse. CAH. So cosine is adjacent over hypotenuse. And lastly, tangent, opposite over adjacent. SOH CAH TOA is going to help you guys with these three ratios. Now, let me separate it. Here's some space. There's going to be 3 other ratios, because as I said, we're going to do a total of 6. The other ratios, we're going to call this cosecant. We're going to have secant and cotangent. Now, cosecant, I cannot use just the first 3 letters, because COS, I already used it for cosine. So the way we're going to abbreviate cosecant is going to be CSC. I'm going to do cosecant of theta. Secant, I'm going to abbreviate that using the first 2 letters, so CEF, so secant of theta. And cotangent, I'm going to go COT of theta. Right, again, I'm going to abbreviate that using the first 3 letters. Let me start with cotangent. If you notice, tangent was TAN and cotangent is COT. Kinda looks like tangent backwards. So cotangent is going to be the reciprocal of tangent. Remember, reciprocal is basically a fraction flipped upside down. So cotangent is going to be the reciprocal of tangent. So cotangent, let me write this in blue here. Cotangent is going to be adjacent over opposite. And then secant kind of looks like cosine backwards, right? Cosine was COS, secant is SEC. So kind of looks like cosine backwards. Secant is the reciprocal of cosine. So secant is going to be hypotenuse over adjacent. And as you guys might expect, cosecant is going to be the reciprocal of sine. So cosecant will be the hypotenuse over opposite. Right now you might be, oh, this is some mumbo jumbo. All right, that's how we see it right now. What we're going to be doing is we're going to be writing fractions. This thing is going to help you guys out. SOH CAH TOA help you guys remember sine, cosine, and tangent. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So let's take a look at how we're going to work these things out. Looking at question number 1. First of all, label the 3 sides. Remember, hypotenuse is the biggest side. So let me just call this H for hypotenuse. And then I see theta. I see where theta is given. So this corner. From based on theta, I know the side that is farthest away we call opposite. The side that is close to we call adjacent. So let me call this O for opposite, and let me call this A for adjacent. And then cotangent, let me come back to my chart. Cotangent is adjacent over opposite. So adjacent over opposite. So in this case, it's going to be 3 over 6. Simplify your fractions. Obviously, if you have a fraction, do simplify your fraction. If you have radicals, as you guys notice, I can have radicals. There's a radical 5. If you have radicals, make sure you simplify. And remember what I mean with simplifying is uh, your number is as low as possible. Remember, we learned how to simplify radicals. And when you have fractions, which in this case we will have fractions, no radicals at the bottom. So remember that. So now here we have 3 over 6. Simplify the fraction, divide each number by 3. So I'm going to call that 1 over 2. Make sure you simplify the fraction. If this was my homework and I type in 3 over 6, I submit it, it's going to tell me it is wrong. And the reason why it will be wrong is because I did not simplify my fraction. So make sure you simplify it. Notice also, we've been typing fractions with a backslash. Notice I'm keeping the same idea. 1 over 2, I typed it as 1 backslash 2. Okay, that one wasn't too hard. Now sine, I see my theta, so this is my theta. Let me label my 3 sides. The biggest side is the hypotenuse, which in this case is this side. Based on theta, 12 is the opposite, 5 is the adjacent. Remember, opposite means far away, adjacent means close to. I remember my sine, I remember my chart. The chart said the sine was opposite over hypotenuse. When I mean chart, I'm talking about this right here. Okay? So from now on, if I say chart, this is what I'm talking about. Okay, so now sine, I know is opposite over hypotenuse. So in this case, 12 over 13. Don't have radicals at the bottom. Don't have radicals at all. 12 over 13 is as simple as I can do. So that's it. My fraction is 12 over 13. So when it says find the value of the trig function indicated, so trig is for trigonometry, I'm looking for a ratio. Remember, ratio is the fancy way of saying fraction. So we will have fractions. Now, looking at here, question number 3, I'm still going to ask you guys for the same idea. Find the value of each trigonometric ratio. So I even said the whole word now, trigonometric ratio. Again, ratio is just the fancy way of saying fraction. But now here I don't have a theta. Instead, I have tangent of A. I notice that my corners, one of them is A, there's a B, and there's a C. What I mean with that is that at corner A, that's where we will be placing our theta. So in this case, I have to write my theta because it's not there. Let me label my sides. The biggest side is my hypotenuse, so 40 in this case. Based on theta, the side that is farthest away is my opposite. So 24 is my opposite, and then 32 is my adjacent. And according to the chart that we have, tangent is opposite over adjacent. So I'm just going to go 24 over 32. If I just leave it as 24 over 32, and this is a homework assignment, it will be marked incorrectly. And the reason why is because I haven't simplified. 24 and 32, they can both be divided by 8. Let me divide each number by 8. So that's going to give me 3 over 4. And that will be my answer, 3 over 4. Don't forget to simplify your fractions. Now let's take a look at question number 4. Today, I'm going to be working up until number 8. So let's take a look at number 4. Let me label my sides first. I know the hypotenuse is easy. I can just label the H for the biggest side is hypotenuse, but I don't see my theta here. It says cosine of x. That's what I've been asked for. And I see my corners are z, x, and y. So cosine of x, what that means is that at the corner x, let me write my theta. So if it said cosine of z, I'll write my theta at z, but here it says cosine of x. So I'm going to do my theta at x. And based on my theta, 40 is my opposite and 30 is my adjacent. Remember, opposite means far away, adjacent means close to. And then I'm going to be looking at cosine. I know the acronym for cosine, for CAH, remember our SOH CAH TOA, I know cosine is adjacent over hypotenuse. Remember our chart, adjacent over hypotenuse. So in this case, let me call this 30 over 50, right? Adjacent over hypotenuse. Simplify your fractions. 30 and 50, they can both be divided by 10. So let me divide each number by 10. So that's going to give me 3 over 5. So writing the ratio so far has been simple, right? Make sure you know how to label the sides as hypotenuse, opposite, and adjacent. Some cases, like you guys see questions number 1 and 2, theta was given. You had the theta on the picture, but questions 3 and 4, you had to draw theta. So make sure you understand the difference of the questions. But now that we know the ratios, we're going to learn how to use them. Question number 5 and 6, we're going to use this to find the value of a side. We're going to measure the side. Question number 5, I see the hypotenuse is 18. I have an angle measured 20, and I'm solving for x. Just from the figure, I can tell that x is less than 18, right? X is smaller than 18. So a number smaller than 18 is what I'm expecting. If I'm doing my work here and I get something more than 18, very likely I'm doing something wrong. Okay, so I'm expecting something less than 18. Okay, so let me label the size that we have. Right there, the 20 degrees, that's where theta will go. So we're looking at, remember I said theta was the angle, the Greek letter that meant measurement. 20 degrees is a measurement, so that's our theta. That 20 degrees is our theta. I know 18 in this case is the hypotenuse, is the biggest side of the three. And based on our 20 degrees, based on our theta, I'm going to say x is our opposite. Okay, so x will be our opposite. So now let me write the ratio. Let me write the fraction how I know this. O and H. I'm thinking, is that sine? Is that cosine? Is that tangent? Is that cosecant? Is that secant? Is that cotangent? Let me remind you guys of an acronym. SOH CAH TOA. That gave me sine, cosine, tangent. According to our calculators, most calculators, they only have sine, cosine, and tangent. So I'm not going to be able to use, on my calculator, I'm not going to be able to use cosecant, secant, and cotangent. That's most of them. If you have a calculator that has all 6 ratios, then by all means, feel free to use it. Okay, so in my calculator, I have a TI-30X. The calculator you guys have access in Canvas, it's kind of like a TI-30X. It only gives me sine, cosine, and tangent. So I'm looking at those 3 cases. Which one do I use, O and H? And we're going to say sine. We use it in sine. Okay, so I'm going to use sine. So let me write this as sine of 20 degrees is equal to, I know it's opposite over hypotenuse, so let me go x over 18. Now, it is nice when in a fraction when x is on top. It is nice. Not always, we're not always going to have x on top. It is nice when x is on top because I can easily get rid of fractions by multiplying both sides by 18. Right, this 18's cancel out, so I get x by itself. Like I said, it is nice when x is on top. Now I'm just going to go 18 times sine of 20. Now, if you're using a calculator in Canvas, you're really just going to type in as it is. You're going to go 18 times, and then you use the key that says sine, and it's going to open parentheses there. You just type in 20. Don't forget to close your parentheses, and then just press enter. Now, one big thing, make sure you have this on degrees, okay? Make sure you have this on degrees because that's what we're measuring with. I believe it starts on radians, so make sure you change it to degrees. So let me show you guys how it is done in a calculator. So let me bring up calculator from Canvas. Let me share that right now. So I had to type in 18 times sine of 20. One thing to begin with, notice here on the left side, here where I'm pointing, it says RAD. That's radians. Now, we don't want to use radians. In a circle is broken down into about 6.28 radians. We want to use degrees. So make sure this dotted line, you switch it over because you want to have degrees, okay? We're dealing with degrees. So I'm just going to type in 18. Remember, I have to type in 18 times sine of 20. Let me see this right here. So I'm going to go 18 times, I see sine here. So sine opens parentheses, 20. Don't forget to close your parentheses. So look at the screen. It says 18 times sine of 20, and I pressed enter. Boom, it gives me a bunch of numbers, right? It gives me a decimal place. Now, on the instructions, I'm going to ask you to round it to the nearest tenth. Now, we talked about it last week. Tenth, when it ends on a TH, that means a decimal. Tenth sounds like number 10, a 1 with 1 0. So that means 1 decimal place. If I said hundredth, 100 sounds like 100, a 1 with 2 zeros. So I will mean 2 decimal places. Okay, so I mean nearest tenth. So for right now, let me just write this with 2 decimal places. Even though I needed to write 1 decimal place, let me write this 2 decimal places. So according to my calculator, I got 6.15. All right, I got that. Now be careful. I recommend you guys using the calculator from Canvas. The reason why I ask you guys to do that is if you guys use the one from your phone, if you guys are using the one from your phone, it's different. If you guys, especially if you guys are typing in with an iPhone, sine of 20, you have to do it backwards. You have to do 20 and then press sine. You need help on how to type it on your calculator, contact me. But I highly, highly recommend use the one that I'm giving you in Canvas. That's the one I'm going to use for my lectures. Okay, so 6.15. I have to go to the nearest tenth. I do take a look at the second decimal place. It is big enough. Remember, we talked about last week that big enough is 5 or more. Because 5 is big enough, it's going to push the previous number. So the 1 is going to push it up. So my answer in this case will be 6.2. Okay. Okay, that was not that bad. 6.2. I expected 18, x to be less than 18. So it makes sense. Now let's take a look at number 6. Let me label the size that I have. In this case, x is the hypotenuse. I'm going to say x is the hypotenuse. And according to my 16 degrees here, that's a 16 degrees. According to my 16 degrees, I'm going to say 12 is going to be my adjacent. I don't have the opposite in this case. And then A and H, I remember the acronym CAH, right, is the acronym that uses A and H. So that means that cosine, in this case, let me write cosine of 16 degrees is equal to 12 over x. Okay. It was nice when x was on top. Now when x is at the bottom, let me just get rid of fractions. I remember cross multiplying. Okay, so let me write this as cosine 16 over 1. I remember cross multiplying, so I'm going to go x times cosine of 16 is equal to 12 because I just multiplied. X times cosine of 16 was 12 times 1. Then to get the x by itself, let me divide by cosine of 16. So x is equal to 12 divided by cosine of 16. Okay, let me come back to the question to begin with. Remember, beginning we had cosine of 16, it's equal to 12 over x. When x is on top, like we saw in number 5, it's easy, just multiply it. When x is at the bottom, look what I did. I divide. 12 divided by cosine of 16. I showed you right now using cross multiplying, just so you will know where the division comes from. But from now on, you can just divide. To make it easy, x is equal to 12 divided by cosine of 16. Okay, let me share my calculator now. Remember, I'm using a calculator from Canvas. So let me clear this out. Make sure you're still on degrees. And I'm going to go 12 divided by cosine of 16. Close my parentheses, press equal. Bunch of numbers, right? A long decimal number. For right now, let me just copy it up to 2 decimal places. So 12.48. So I'm just going to write right now 12.48. I take a look at my second decimal number. In this case, it is big enough, right? 5 or more is big enough. So because it is big enough, it pushes the previous number up. So instead of 12.4, I'm going to write 12.5. Okay, not bad, not bad. Now, we can use our ratios, our trig ratios, to solve for a side. We can also use it to solve for an angle. Looking at question number 7 and 8. Find the measure of the indicated angle to the nearest degree. Okay, so nearest degree means nearest whole number. My answer will be as a decimal. When I type this on a calculator, I'm going to get this as a decimal, but I'm going to round it up to the nearest whole number. Okay, so let me identify the size that I have, right? The angle here, kind of blurry, but the angle on your notes, if you're printing your notes, it's a question mark. I don't know what a question mark is, so every time I don't know the value of something, I replace it with X or, a letter. So right now, let me call it X. Let me label the two sides that I have. First thing I ask myself is, do I have the hypotenuse? That's the biggest side. And yes, 35 is the hypotenuse. Then I ask myself, the other side, in this case, 16, is that the opposite or the adjacent? And we're looking at X as our theta, okay? X is our theta. So then I'm asking, is 16 the opposite? Is it the far away? Or is it the adjacent, the one that is close to? In this case, it's the opposite. For my acronym SOH CAH TOA, I'm going to use the acronym SO. What that stands for is sine is opposite over hypotenuse. So I'm just going to write sine of x is equal to 16 over 35. If I go 16 divided by 35, it's going to give me a decimal. I don't have to simplify my fractions. This one cannot be simplified, but if it could, don't worry. Don't simplify if you're going to use a calculator. Now here, I wish I could have x by itself. I wish I could move the sine part to the other side. Sine of x is an entire number. I cannot just move part of it unless I use this thing called inverse. So I'm going to have x by itself, and I'm going to move sine to the other side, but I'm going to call this sine inverse. My sine inverse, let me write it as sine to the -1. I'm not using -1 as an exponent. I'm just writing this because that's how calculators have it. But we read that as sine inverse. As a matter of fact, let me put inside parentheses here, 16 over 35. Like I said, I'm calling it sine inverse. Some people call it arc sine. Okay, but there, I just need to type that in. So let me bring on my calculator here. And then here I'm like, I don't see sine inverse. However, I see this key that says second. Some calculator says shift. Okay, so I'm gonna press second, And oop, I get sine inverse right there. Make sure you use sine, not sinh. This one with an H, we call that sinh. That's a whole different thing. I'm gonna use sine, so this sine. Okay, so let me clear this out. And I'm just gonna go sine inverse. Notice how my calculator it wrote a sine for arc sine. Remember, some people call it sine inverse, some people call it arc sine. Okay, so I pressed my sine inverse. Let me type this in as 16 over 35. That way I'm going to type 16 over 35. I'm going to go 16 divided by 35. And then I close my parentheses. So I do see that it says sine inverse or arc sine of 16 over 35. And then I'm going to press enter. Now it gave me a decimal, 27.2. My decimal is too small. Remember, 4 or less is small, so I'm going to ignore it. Remember how I said that the answer was going to be given as a whole number? We're going to round it to the nearest whole number. So in this case, 27. Okay, 27.2 gets rounded to just 27 degrees. I'm just going to write the number 27. We don't have a key, easy key to write degrees, so you don't have to write the word degrees either, just 27. So that's 27 degrees. Wow, pretty cool. Now let's take a look at question number 8. My question mark here, let me call it X. Let me label the two sides that I'm given. 38 is the hypotenuse and 29 is the adjacent. Remember, adjacent is close to, opposite is far away. From my acronym SOH CAH TOA, I'm going to use the acronym CAH. What that stands for is cosine is adjacent over hypotenuse. So I'm just going to write cosine of X is equal to 29 over 38. To get X by itself, I'm going to use inverse. So X is going to be cosine inverse. Again, some people call it arc cosine. Cosine inverse of 29 over 38. Again, I recommend you guys use the calculator given in Canvas. Otherwise, it makes it a little harder to work with. So let me use my calculator here. I'm gonna type this in. So I see cosine inverse, right? Have it on degrees. Make sure you have it on degrees. And then I'm gonna say cosine inverse. 29 over 38, I type that in as 29 divided by 38. Close my parentheses. According to my calculator, I get 40.2. That decimal number is too small, so I'm just going to ignore this. I'm going to ignore the decimal, so I'm just going to call this 40 degrees. Don't forget to round if necessary. So we're going to round it to the nearest degree. So when I'm asking for side, question numbers 5 and 6, I'm expecting a decimal to the nearest tenth. When I'm asking for angle, looking at question number 7 and 8, I'm expecting a whole number. Even though my calculator gives me a decimal, round it to the nearest degree. Round it to the nearest whole number.